Today, I am going to deal with CPU scheduling. What are the basic criteria of CPU scheduling? And along with that, FCFS. That is the first come, first serve scheduling algorithm. So, firstly, I am covering up the CPU scheduling criteria. Why we are choosing the CPU scheduling criteria? This is the one of the important factor. In a multi-programming environment, there may be more than one program reside in the memory and they execute concurrently. So to achieve this, there is a switch over from one process to another process. So there some of the process may be shorter, having the shorter time. Some of the process may take longer time. So there should be a good mixture so that there should not be any starvation condition. To overcome such type of problems, we are using the some of the criteria. Different algorithms are made based on these criteria. So first is the CPU utilization. CPU utilization should be maximum because see, a processor or a machine should not sit idle when it is turned on. So to take the maximum performance, we should run or design an algorithm that can continuously assign a task to the processor and processor remains busy in that. The CPU's utilization varies from 0 to 100%, but in general, it is in between 40 to 90% in real life. Throughput. Throughput is the basically amount of work done in unit time. How much work is done by the processor at a particular unit of time. So work done should be maximum. Third one is the turnaround time. Turnaround time is basically sum of number of times that a process has spent in the number of queues such as waiting queue, ready queue, executing a process, waiting for input, and so on. That means from submission to completion of the process, the time a process spends is known as the turnaround time. Now, waiting time. When a process arrives in the ready queue, this may be possible the processor is not assigned to it because some of the process is already executing by the processor, or suppose that the process requires some input out perform to perform the some input output action, and that input output device may be busy to serve any of the other process. For example, a printer. I need a I need a printer to execute or to complete our task. But some other process is already given the task to the printer and printer is executing that. So my task has to wait or my job or my process has to wait for the printer. When it will get free, it will execute my task. So there is a waiting time that or the waiting queue. There is a waiting queue. The process will spend the time in the waiting queue. Then after response time. Response time basically when a process is submitted and we are getting the first response from the process side that it has started that. For example, if I am using a media player, so as I am double clicked on the media VLC media player, and as the first frame of the picture appears in front of me, so that is the response time. Now Again, I am summarizing. CPU utilization must be maximum. Throughput, that means amount of work done, should be maximum. Turnaround time should be minimum. Waiting time should be minimum. And response time should be minimum. So these are the basic criteria at which the CPU scheduling algorithm are designed. Now, various times of the process. When a process is going to execute, so some of the time or elapsed by the process are known as arrival time, waiting time, response time, burst time, completion time, and turnaround time. So first one is the arrival time. It is the time when a process comes in the ready queue from the secondary pool, means hard disk. Completion time, when a process get complete its execution. It is also known as the exit time. Next one is the burst time. Burst time basically the amount of time that a process requires CPU to be spent on CPU. Next one is the turnaround time. Turnaround time basically it is the completion time minus start time. Means when a process arrives, start time is also known as the arrival time. So when a process completes and minus subtraction of arrival time. For example, a process completes in 10 unit of second and it arrives after 2 seconds. So the turnaround time will be 8 seconds. Similarly, waiting time. Waiting time is the turn, defined as turnaround time minus burst time. For example, a process get completes after 10 milliseconds and it executes by the processor only for 4 seconds. Then 6 seconds is the waiting time for that process that may be spent on the ready queue, maybe for input output waiting, and so on. Next one is the response time. It is the basically time at which the process get first response by the CPU minus arrival time when it arrives. So here I am going to now discuss first scheduling algorithm, that is the FCFS. It is the simplest and easiest one algorithm and it is very easy to implement. The jobs are executed on the first come first serve basis. For example, there are 10 jobs P1, P2, P3, P4. So firstly P1 will execute if it arrives in the ready queue. For I am taking the example here. Suppose that there are three process P1, P2 and P3 and all arrives at the time 0 seconds. Arrival time is the 0 second. So in the order in which they arrives, the processor will execute. So here will be the execution sequence will be P1, P2 and P3. Now suppose that the P1 arrives not at the time 0. It is something else. For example, I am taking here as the arriving time 3 second, 2 second and 1 second. So in that case, firstly all the 0 second let करिए, it is a 0. So firstly P3 will get execute, then after P2 will execute, then after P1 will execute. So this is the arriving, it depends on the arriving time when a process arrives, according to that, the execution sequence will be. It is a non-primitive scheduling algorithm. Non-primitive means no one can fetch or take over the controls from this process. Means once this process has starts the execution, it will execute completely. Then after once it will get completed, it will voluntary voluntary leaves the processor. No one can snatch. The performance is poor as the average waiting time is high. Since suppose that there are a process that is has the lesser time and a longer process is executing at present, so the average waiting time for that process or all the process will be higher, especially the waiting time for the smaller processor will be much higher. As the process enters into the ready queue, PCB is linked on the tail of the queue. This we have already discussed in our previous lecture. When a CPU is free, it is allocated to the processor at the head of the queue. Now, convoy effect. Suppose that there are three processes P1, P2 and P3. We can understand it better by an example. The P1 requires 100 millisecond, P2 requires 2 millisecond and P1 requires 1 millisecond. And all are arrives at the time 0 in the ready queue. So it the order of execution will be P1, P2 and P3. Now the P2 process has to wait for the 100 millisecond in the ready queue because the processor cannot be snatched by the process P2 until P1 will not yet leave voluntary. So the waiting time of the P2 process will be 100 millisecond and for the process P3 will be the 102 millisecond. So while the process P3 can execute only 1 millisecond and get leaves the system, but here it has to wait for the 102 millisecond. So the waiting time, average waiting time is much larger. So convoy effect shows or says the smaller process has to wait the longer in the FCFS algorithm. Consider the process with the higher burst time arrived before the process with the smaller burst time. The smaller process has to wait for a longer time for the longer process to release the CPU. Until the P1 will not release the CPU, P2 and P3 has to wait. So this is the one of the drawback of FCFS and it is known as the convoy effect. Advantage: it is simple and easy to understand. It can be easily implemented using the queue data structure. It does not lead the starvation because after certain amount of time, definitely the processor will be allocated to that particular process that may be a smaller. Disadvantage: it does not consider the priority or the burst time of the process and suffers from the conveyor. Now, consider the example of FCFS. As we know that FCFS is the scheduling algorithm in which the processor is allocated to the process that have come first in the ready queue. So here arrival time is specified and waiting time, burst time is specified. So we are considering the five process P1, P2, P3, P4 that have the arrival time given and bus time is also given. We have to find out the average waiting time and average turnaround time. So how will it get calculated? Let us see. So firstly, we should make a Gantt chart. At the time 0, there is only one process, that is your P3 is in the ready queue. So it will immediately allocate it to the processor and execute for the 2 milliseconds. After execution of the process P3, it will search for the processor will search for the another process in the ready queue, but there is no process in the ready queue. The next process arrives at the time 3 unit of 3 unit. So processor will sit idle for the 1 unit of time. When next process arrives, that is the P1 arrives, and it requires a burst time of the 4 unit of time. So P1 will get execute for the 4 unit of time. Then after, at the time unit 4, a new process P5 arrives. It will execute for the 3 unit of time. So here is the P5 will get execute, and then after, at the 5 millisecond, two process arrives simultaneously, P2 and P5. Here is the tie. So we will consider the process which have the least number. That means P4 in and P2. P2 has the least number, so it will be taken into the consideration, and it will execute for the 3 unit of time, and then at the last P4 for 1 unit time. So this is the Gantt chart. Now, how can we calculate the average? How can we calculate the turnaround time and waiting time? We have already gone through the formula. The turnaround time is defined as completion time minus arrival time. So here for the process P1, for the process P1, P1 get completes at the time of 7 unit, and it arrives at the time unit 3. That means 7 minus 3, it is equal to 4. P2. P2 completes at 13 millisecond or 13 unit of time, and it arrives at 5 unit of time. So 13 minus 5 is equal to 8. P3. P3 completes in 2 unit of time and arrives at 0. So then 2 minus 0. P4. P4 get complete at 14 unit of time and it arrives at 5 unit of time. So 14 minus 5 is equal to 9. Now coming on the P5. P5 completes at 10 unit of time and arrives at 4 unit of time. So 10 minus 4 is equal to 6. So this is the process by which we can calculate the turnaround time. Now coming on next, waiting time for each process. So as we know that the formula for waiting time formula is the waiting time is equal to turnaround time for that process minus uh, minus bus time. So here, what will be the bus time? Let us see. So P1. P1's turnaround time is the 4 minus bus time. Bus time for P1 is also 4. So 4 minus 4 is the 0. P2. P2's turnaround time is the 8 millisecond and bus time is the 3 millisecond. So 8 minus 3 is equal to 5. For P3, turnaround time is the 2 millisecond or 2 unit of second, and it requires 2 unit of time. So turnaround time minus bus time is equal to 0. That's why for the process P4, P4 the turnaround time is the 9 and bus time is only 1 unit of time. That's why it is 8. And for the process P5, turnaround time is the 6 unit of time, and the bus time is the 3. That's why it is 3. Now, how can we calculate the average? It is very simple. We can add all the times divided by the number of process. So here is the 4, 8, 2, 9, 6 divided by the number of process. Those are 5. So I can get the average turnaround time. Similarly, for the average waiting time, we will add all the times waiting times of process, all processes, and divide by the number of process. So 05083 and summation of these divided by the number of 5. So I can get the average waiting time. Now moving to the next example. Here I have considered three processes P1, P2, P3, and arrival time is also given and bus time is given. Now firstly make the Gantt chart as already discussed. So arrival time. So firstly at the time 0 there is only one process, that is the P1, that will execute for the 2 millisecond. Now next process arrive at the 3 millisecond, so processor will sit idle for the 1 millisecond, and then after execute for 1 millisecond, so 3 to 4. Now after next process arrive at 5, so there is another gap of the 1 unit of time, and then after it will execute for the 6 unit of time. So P3 get completes at 11 unit of time. Now how can we calculate the turnaround time and waiting time? As we have already discussed in the previous question. So turnaround time is the completion time minus arrival time, or completion time or exit time minus arrival time. So completion time and exit time are same one. These are the synonyms basically. So completion time for process P1 is the 2 and arrival time is the 0. So 2 minus 0 is the 2. For P2, the completion time or exit time is the 4 and its arrival time is the 3. So 4 minus 3, that means waiting time is the 1, turnaround time is the 1. Similarly, for the process P3, P3 gets complete or exit at 11 unit of time and it arrives at 5 unit of time. So 11 minus 6, 11 minus 5 is equal to 6. Now calculating the waiting time for process P1. Waiting time, as I have already discussed, it is the turnaround time minus bus time. So turnaround time for the process P1 is the 2 minus bus time. The bus time is for process P1 is the 2. So 2 minus 2 is equal to 0. For process P2, turnaround time is the 1 minus bus time, that means 0. For the process P3, the turnaround time is the 6 and bus time is also 6. So again it is 0. So average waiting time is the 2 plus 1 plus 6 by 3, because there are 3 processes. It is a 3 unit of time, and average waiting time is the sum of all waiting times by the processes divided by number of processes. So it is the 0 amount of time. So no process has to wait in the ready queue or the waiting queue for the processor. So this is all about the FCFS algorithm from my side. Thank you.